Right. So today we're looking at worksheet 10N. It is the last of the worksheets. So in number 1 we are given BF. Let's show it in the F thing. We're told that BF or DF is equal to FC, and FE is parallel to CB. So this plays straight into the midpoint theorem. So that means to say that length is equal to that, and then BC is double EF. Then we are told that triangle ADE is an equilateral triangle, which means to say, there is 60, 60, 60. Okay. The question says prove that AEB is an isosceles triangle. ABE is an isosceles triangle. So for this to be an isosceles triangle, those two angles will have to be equal. Why? Because this angle here, of course, is going to be 120 degrees. Why? Because why? Angles in a straight line. Okay. So let's list that. So you got AEB is equal to 120 degrees straight line. Okay, so let's put 120 there. Again, for this to be an isosceles triangle, this angle here has to be equal to that angle, or that side is equal to this side, basically. Okay. We didn't actually need this 120 here. So let's take this out. So I see it now. It's a bit easier than what I thought. So let's go with it. So we're going to prove, since that is the midpoint theorem, as I said, that this angle here, that length will be equal to that length. Okay, and since this is an equilateral triangle, that length and that length is also equal to that length. So then those two lengths are equal. It's an isosceles triangle. Two sides of the triangle being equal. So let's lay that out. We firstly state the obvious. So DF is equal to FCY. Given. And then we know that FE is parallel to BCY. It's also given. So therefore, DE is equal to EB. Why? Because of the converse of the midpoint theorem. Okay. The converse of the midpoint theorem. So they've got the same marking. Then we can say that DE is equal to DA, which is equal to AE. And where do we get that now from? From the fact that triangle AED is an equilateral triangle. Since that's an equilateral triangle, all those lengths are equal. So since, we state the obvious, since AE is equal to EB, proven, so therefore AEB is an isosceles triangle. Why? Because two sides are equal of triangle. Two sides of the triangle are equal, so it has to be an isosceles triangle. Okay. If you have if I had made any mistakes or there's an easier way of doing something, please contact me on that number. These videos are free. Alright. Okay, now we're looking at number 2. In number 2, we are told that EDCG is a parallelogram, which means to say that marking and this marking will be the same marking. Okay, why? So opposite sides of parallelogram are equal. Then we are told that DF is equal to GB. Okay. But this is also equal. Why? Because the diagonals of a parallelogram are equal. Bisect each other equally. No, bisect each other, not equally, bisect each other. Diagonals bisect each other equally in two shapes, in two quads, which is namely a rectangle and a square. Then we are told that DE is equal to AG. Okay, as you can see, it's marked there already. The question says, prove that if CBA, if CBA is a parallelogram. They are laid it out for you already. You see that is equal to that, that's equal to that. There is a parallelogram, diagonals bisect each other. Okay, so let's make it official. Okay, firstly we're going to say that ED is equal to GC. Why? So opposite sides equal in a parallelogram. Okay, then ED is given equal to AG. DG is equal to AG. Where you get that from? Given. So therefore AG is equal to GC. But that's not proven. That's the one diagonal being equal, right? Then we know that FG, now the second one, FG is equal to DF. That is equal to that. Why? Because diagonals bisect in parallelogram. Okay, diagonals bisect in a parallelogram. But DF is equal to GB. That was given. Therefore, FG is equal to GB. Proven. So you see now that is equal and that is equal. Okay, so since that is equal, those lengths are equal and these lengths are equal, therefore ABCF is a parallelogram. Why? Because the diagonals bisect each other. Okay, therefore it's a parallelogram. Okay, let's look at number 2. In number 2 they want you to prove, let's just get the other column. Number 2 they want you to prove that AB is equal to EF. So AB is equal to EF. This here. Okay. But AB is equal to FC. Opposite sides of a parallelogram is equal. And then EF is equal to FC. Why? Because the diagonals bisect each other in a parallelogram. So since it has the same markings, therefore it's equal. So let's write that down. So you're saying that AB is equal to FC. Why? Opposite sides equal in parallelogram. Okay? Then we said that, that's officially that there. Then we're saying that FC is equal to FE. Why? Diagonals bisect in parallelogram. Diagonals bisect each other in the parallelogram. So therefore, we have answered the question now that AB is in fact equal to EF. Okay, that was a good one. Alright.